Hello guys, welcome back to our YouTube channel. In the previous video, we talked about sine rule and then cosine rule. So in this video, we'll be talking about some of the questions, like we'll be solving some questions under trigonometry 1, and then in the next video, we'll be moving to trigonometry 2, which will be compound angle and formula. So without much ado, let's dive into solving our first question. So our first question is to find the values of what sine A and cos A if tan A is what 3/4. Okay, now tan A to be 3/4, we need to draw negative 3/4, right? So let's draw that using the Cartesian plane. Using the car system. So we know that for tan to be positive, it's either here or here, right? So for it to be negative, it should either be at this place or this place, right? So we'll be having two types of values. So one when it is here, and the other one when it is at this side, right? Okay, so let's start. So first, let's consider. Let's say the angle is in what, the second quadrant, right? So second quadrant. Let's say the angle is in the second quadrant. So that way we can draw our angle to be, so let's say this is our angle here, our angle A. Then we have this, right? And we know that tan is what? So which is like opposite over adjacent, right? So the opposite will be 3, and then the adjacent will be what? -4, because this is the negative x-axis and this is the positive what? Y-axis, right? So we can find the hypotenuse. So when you do the hypotenuse squared will be equal to opposite squared plus what? Adjacent squared, and here that would give us what? 5, right? That will give us 5. So from here we can find our sine A, to be equal to what? Opposite over hypotenuse, so opposite, which is this. And then we can find our cos A to be equal to what? -4 over what? 5. Okay, so realize that in the question they talk about values, so you should know that they are not expecting only one value. Now the next this one is when we consider that it is what? In the fourth quadrant, right? So if it's in the fourth quadrant, that one, when you draw it, it will look like this. An angle A, right? Then you have what? Opposite, which is 3. It's actually -3. Then the adjacent is what? 4. And then when you solve, you still get your hypotenuse to be what? 5, right? You still get the same hypotenuse, which is 5. Then from here you can also go ahead to find your what? Sine of A, which will be equal to what? Opposite, which is negative this over 5, and your cos of what? A will be equal to what? Negative what? Not negative. It will be 4/5, right? So you can just basically solve them, and then you assign the signs later. You can see that here is 3/5, 3/5, 4/5, 4/5. Then you come to their respective quadrants and then add the signs. Okay, so this is our first question, and then this is the idea behind it. Now let's move to our next question. So our next question, you have to solve the triangle given that angle B is what? 79 degrees. Length of AC is 22.31 meters, and BC is this. So the best thing you can do is what? To draw this triangle, right? So let me try and see if I can sketch something. Yeah. So A, B, C. Angle B is 79. Then AC is 22.31 millimeters. Then BC, this one is 17.92 millimeters. Right. So I'm sure they are asking us to find like AB. Okay, I'm sure they're asking us to find the length of AB. So what's the length of what? AB. That's what we are looking for. So from here we know that we are given what? Two sides and what? An angle, right? Two sides and an angle. So with that we can use what? Cosine rule to find for what? The third side, right? So using cosine rule, we'll use the one that we know. So AC squared will be equal to what? AB squared plus BC squared minus 2AB BC cos of what? B. Right, so this is what we'll be using. So we have 22.31 millimeters, so just squared to be equal to, we don't know AB, that's what we are looking for. So AB squared plus 17.92 minus 2 times what? The length of AB multiplied by what? 17.92. Then cos what? 79. When you do that, so let's make length of AB to be equal to what? Small a. I'm trying to simplify this side. So this is also squared. So 22.31 squared minus 17.92 squared. If you remove this from that, you get, so I'm sending everything to this side. So I have a squared minus 176.6 multiplied by what? 2 times 17.92 cos 79. That will give 6. So minus what? 6.838 a, and then this will be equal to what? 0. So we'll have a squared minus 6.838 a minus 176.6 to be equal to 0. So you realize that this is what? A quadratic equation. So when you solve that quadratic equation, you get a to be equal to 17.14 millimeters. You get two answers, which is also the other answer is negative 10.3 millimeters. But then the length cannot be negative, so we will not take this one. We'll only focus on the 17.14 millimeters. Okay, so that's how you go about. So we use cosine rule to solve this kind of question, and we have solved some examples when we are talking about the cosine rule. Okay, now let's move to our next question. They say solve the figure below, and then we are supposed to find what's the possible values of x. So you should take note of the questions. They say you should find the possible values of x. This means that there is the probability that we have more than 1x is very, very high here, right? So let's see. So what do we have here? We have two sides, right? No, we have two sides, one angle, and they ask us to find the third side. The only thing we can use here is what? The cosine rule, right? Is the cosine rule. So we just take the cosine rule around here, and then you focus on the one with the angle. Okay, that's the one we start with first. So here you have what? 13 squared to be equal to what? 15 squared plus what? X squared minus 2 times 15x equals what? 60, right? So I'm sending everything to the other side. So I'll be having 0 is equal to what? Minus 13 squared plus x squared minus what? 15x. 15 squared minus 13 squared. That should give us what? 56. So we have x squared minus 15x minus 56 to be equal to what? 0. So to solve this, you just need to find two factors of what? 56. That when you add, you get what? 15. And that's what? 8 and what? 7, right? Or you can use your calculator to solve it. This is, yeah, this is plus, not minus. Okay, I wrote minus, supposed to be plus. So that's where my mistake is coming from. So when you solve, you get your x to be equal to 7 or what? 8. So these are the values that they are looking for. So therefore, x is equal to what? 7 or 8. So you realize that you have x centimeters here. So you don't really need to add centimeters. They're just looking for x. You have it to either be 7 or 8, right? Okay. Now the next thing that we'll be talking about is we want to solve some examples, some proving examples. Okay. So if they ask you to prove that 1 over sec a 1 over sec a minus what? Tan a is equal to sec a plus what? Tan a. We should prove that these two relations are what? Equal. How do you go about that? One of the best ways to go about this is to rationalize this one. So multiply the top and the down by the conjugate of the bottom of the denominator, right? So sec a minus what? Tan what? A. Then you multiply it by what? Sec what? A plus what? Tan A all over what? Sec A plus what? Tan A. Then this will give us what? Sec A plus tan A all over sec A minus tan A multiplied by what? Sec A plus tan A, right? So this will give us what? Sec A plus tan A, there's a plus here, all over what? Sec squared A, because the bottom is now what? Difference of two squares, right? Minus tan squared A. And then if you remember, we talked about what? The trigonometric, this one, identities, right? I think the second one, yeah. So realize that you have tan 1 plus what? Tan squared A is equal to what? Sec squared A, right? So 1 will be equal to sec squared A minus what? Tan squared A. So it means that the whole denominator here can be replaced with 1. So this will be equal to what? Sec squared a plus what? Tan a. Sec a plus tan a all over 1, right? You don't really need to write it. So realize that this is the same as what? This side, right? So it means that what? We have proved the expression. Yeah, so that's one of the things that I want you guys to take note of. And also you can be asked to, like, let's say you are asked to evaluate, let's say, sine of 60. Evaluate what? Sine 60 over what? Cos what? 60, right? Automatically you realize that this is the same as what? Tan 60. But let's say we don't know this is the same as tan 60, so let's just evaluate. So we know that of course we know that sine 60 is the same as what? Square root of 3 over 2, and then cos 60 the same as what? 1 over 2, right? So this will be equal to square root of this over 2 times what? 2, which will give us square root of what? 3, right? So that's also one example. So what if we are asked to convert the following angles? Let's say we have convert 15 degrees to radians, right? So let's convert 15 degrees to radians. We know that's what? Pi radians is equal to what? 180 degrees, right? So x radians will be equal to what? 15 degrees. So our x will be equal to what? 15 pi over what? 180. And that will give us what? Pi over 12 rad. Alright. So that's just, so you can, let's just try one more. So let's say you're giving 36 degrees, right? 36 degrees, and you have to convert it to radian. So x will be equal to what? So our x will now be equal to the angle pi over 180. This will go here twice, this will go here 5. So probably we'll be left with pi over 5 radians. Yeah, 36. Yeah, pi over 5 radians. Okay, so these are some of the questions that I want us to talk about. In our next video, we will go to trigonometry through trick 2, where we'll be talking about compound what? Compound and multiple angles. Okay.